Dear students, we'll be starting in another 1 minute, so please ask your friends to join in soon. All right? Start in another 1 minute. Okay, so good evening, everybody. Thank you so much for joining. It is 4:05, and I thought we'll start off. So, welcome to our first ever masterclass for our AI ML internship, Introduction to Python. So, I do see there are still a lot of us joining. So, I hope if your friends are here, your friends are yet to join, please ask them to join in so that we can start off the session smoothly. So I'm so happy to have you all here and thank you all for taking your time out to be a part of the sessions and upskill yourself in this area. So without further delay, I would like to introduce our speaker for the session. Our speaker is Mr. Amit Tiwari. Amit Tiwari is an AI consultant and trainer with a bachelor's in electronics and communications engineering specializing in artificial intelligence. He is currently conducting research in computer vision and natural language processing. With a wealth of experience, Amit has delivered over 150 sessions, impacting more than 10,000 students. His passion for teaching AI drives him to make an advanced technologies accessible and engaging for learners. So we're so glad to have you here, Amit. Students, can I get some reactions on the screen here, a clap or a heart maybe for our wonderful speaker? Great. Thank you so much. So not taking up any much of your time, Amit, over to you.
Thank you so much, Anne, for this lovely introduction. Hello, everyone. We are back again in this internship. I know that some of you have done the AIML internship previously, but I'm so happy to be back again in this space. Thank you so much, CSR Box, for calling me again for the sessions. All right, so my name is Amit Tiwari, as Anne has mentioned, and I'm here to conduct this machine learning internship, and we are going to have so much fun in this internship. I'm joining in from Ahmedabad. The weather has become really lovely. We are approaching winter now. I hope that from whatever part of the country that you are joined in today, you are also enjoying this little slight winter that we have in our country right now. So without much further ado, I have prepared all these amazing slides for you. And I'm so happy, so glad and proud to see that you have taken a step towards learning and improving your own skills. And that's very much required in the world that we are living in. We are living in an amazing world where we can see all these amazing inventions happening in AI. And we could also see this year itself the Nobel Prize given to the person who was working or who had his research in AI. So certainly AI is the future and we are living in the future. So without further delay, I will just share my slides of machine learning and let's start this session with that. All right, so we are going to master data with machine learning in this internship, and this is the first masterclass that we are going to have today. As I was saying, that we are living in an amazing world where we don't see ourselves not touched by machine learning or AI in our life. So whatever we do or certain things that we do in our life now are dependent on machine learning. So suppose if I'm hungry and I search on Google how to make pasta, so Google gives all these search results to me. So it's not doing it's not hard coded that these websites are the ones which have the best recipes for pasta, but it is learning from its algorithm that which websites should it rank on the top and which websites should it kind of like recommend me to go to if I want to make a pasta. So this is one case where we have seen machine learning. We also have seen machine learning while we are watching Netflix. So this is my Netflix channel, a screenshot of my channel. And because I'm watching all these movies, it is kind of like suggesting me these movies that I should watch or these TV shows that I would love, these recommendations and all. So it is also happening not only on Netflix, but other OTT platforms also. And it is also happening in the shopping platforms that I shop. So if I shop certain item like a shoe, then it will recommend me the other items that I would buy in the future. All this is not happening through hard coding. It is learning from my preferences. It is learning from my data. And this is happening with the help of machine learning. I have my smartphone here with me. If I just type or if I just go to Google Assistant and I ask it, okay, Google, set me an alarm for 4:30 a.m. So it understands what what instruction that I'm giving it to it. It does my task and it also generates the response back that my alarm has been set for 4:30 a.m. We are living in an amazing world right now where almost all the things that we can do with machines feel like a magic. If I talk about like things which not general things which we can do with machine learning, we can also drive cars with machine learning. So this Tesla car is it's a video of a Tesla car being driven autonomously with the help of machine learning. So the driver starts the car, it analyzes where the person has to go using the maps and all, and it drives automatically. There is no use of hands. It is learning from the cameras. It is taking the data from the cameras and the sensors, and it is analyzing which way or which path it should go with the help of the navigation maps that it has. And this has not been done by hard coding everything. That means that we are not feeding the car the whole road or the map. Anything that is there, it is dynamically changing and it is learning from the environment that it is in. So this self-driving car by Tesla is the perfect example of how advanced that we have become in machine learning. So from small things like setting up an alarm or small things like a recommender system where a system is recommending us some other products, or a system where we are or a Google search system, which is an algorithmic system to to help us in finding the right website for the thing that we are searching. Machine learning is being used everywhere. One more example of an advanced machine learning system is the detection of cancer cells. So this is a screenshot of a cancer cell, and with the help of machine learning, we can predict whether a person is having a cancer or not, and it is saving a lot of lives in that process. I was listening to an amazing podcast recently where they were talking about this app called Nuru. So this Nuru app in Africa, the farmers were suffering from their from crop diseases, majorly in tapioca plants. And what the farmers used to do is they would call for some expert. The expert would come and it would analyze the plant, and if you cut the part of plant which was affected by the disease, but that process was very long, and in that process, a lot of crops were damaged. So what scientists did is they trained a machine learning model on the plant diseases, so it could identify healthy plants and the defected part of the plants, and the farmer can use the camera to make a video of the plant, and it would tell which part of the plant is affected, and the farmer can make a decision like cutting that part of the plant, and the plant will grow healthily. So machine learning is being used extensively in all these amazing applications, also in our daily lives, where we can see it being a part of our life now. If I talk about more advanced examples of machine learning, we can also see these autonomous car assembly lines, where machines can automatically just fit all these car plants. It can analyze which part of the which part of the car goes where, and they fix those parts in their places. So we are not telling them how a car looks like, or we are not telling them what part should you put where. They are learning from the whole environment, from the data that we are giving it, from the sensors that we have. And in that process, they are doing all these amazing stuff. All right. So I would request you to also give me some examples in in the chat box where you have seen machine learning. I already have one person who has given me the answer. Mehak says that I saw a video where a car had an emergency assistance system where if a driver passes out, the car takes over and helps to save the driver. Yes, exactly. That's also an example of machine learning. Lahari is saying that chatbot is also where we can use machine learning. ChatGPT is also an example of machine learning. Instagram Reels suggestion is Tijan is saying that that's also a type of machine learning. Facial recognition. Chandrayaan landing. Yes, exactly. Where we are making this Chandrayaan to go and learn from the environment and land it there. Object detection, Google Maps, automatic cars, Amazon recommendations, Zomato food recommendations. I'm reading all of this from the chat box. Thank you so much, those who are replying on the chat box. It is setting up such an healthy learning environment. I'm so proud that you are also being a part of this masterclass. Teaching by robots, Swapnil is saying yes, it can also be a part of machine learning. Image recognition, traffic control, face tracker, is ISRO remote sensing, autopilot mode. So we are also using machine learning for fake news detection. In short, we see machine learning systems all around, and we are living in a world where AI has become a household name. Whatever technology that we are touching in AI is becoming a part of it, right? So Priyanka is saying handwriting suggestion or handwriting recognition, product recommendation, image recognition. Thank you so much for your lovely answers. Let's get started by learning machine learning and also creating our own machine learning systems where we are predicting, we are learning from data, we are using these amazing algorithms. We will also do some coding and programming, all of that integrated. And by the end of this masterclass, we will have our first machine learning system designed with us. All right, so let's do that. All right, so my name is Amit Tiwari. As Anne has already mentioned, I am an AI consultant and trainer for IBM SkillsBuild and CSR Box. I am a bachelor's in electronics engineering, and I have a specialization in AI. And I did my bachelor's back in 2014. So what we were learning in 2014 in AI was all these machine learning algorithms, mathematical modeling. We could not imagine, like I could not imagine that in the next 10 years, that is 2024, we will be able to do all these amazing things with the help of AI and machine learning. Like we could write essays, resumes, articles, poems. We can also draw, or we can just instruct a computer to design me some video, and the computer will design that video for us. It almost feels like magic to me, even if I am a practitioner for the last 10 years, where we have grown in AI and machine learning. I am an AI trainer and practitioner, and currently I am doing research in natural language processing. That means that how computers can understand language, and computer vision. That means that how computers can see the world through the cameras and the sensors. I have taken more than 100 plus master classes for 10,000 plus students, and I welcome you all, those who have joined me in this journey. And I congratulate you that you have taken a step towards your own learning, towards your own skill development. That's a sign of ownership, and I am really proud that you are taking it up. There are some rules of the class before I begin this masterclass. So the first rule is language. I'm really, really sorry for the people who want who want the sessions to be in Hindi or in some other language. I have to use English because there are people from all over the country and also from non-Hindi speaking states. Also, we have some overseas students, students from Africa, students from Kenya. They have joined in. So for that purposes, I will have to use English. But at any point of time you are not understanding my English, or if you want me to slow down or maybe fasten up, do recommend me in the chat box. I take your suggestions really, really seriously. This class is designed for medium to hard level of tech understanding. Some of you will feel it easy, some of you might feel it challenging, but at any point of time you are having any doubt or any misconception, please ask a question. I would be happy to help. Participate. So if you read, you learn. If you hear and visualize, you learn more. But if you participate, you learn the most. So please, please, please participate. I already have amazing participation in the chat box. That means that you are using this chat box to help not only me, but other students. So we are collectively learning together. Also, please take notes unless you have a memory chip, which you can install in your brain and record everything. I'm sure that what we are learning here, you will be forgetting most of it in the coming weeks. So please take notes. If you have a notebook, please grab it, take a pen, and take notes of what I'm teaching in this class. All right, let's begin with basics first. All right. So let's begin with basics first. I will slow down a little bit. All right. Machine learning. So we are learning about machine learning and we see that it's a part of our life now. But what is the definition and what is it exactly? So machine learning is a field of study that gives computers ability to learn without being explicitly programmed. That means that so if you talk about like computers and how we have designed computers, so we have programmed computers to do things like hard coded them to do certain tasks. But in machine learning, what we do is we don't program them. That means that we don't we program them in a way that they learn, but we don't program them to do certain tasks. So they learn from the data, they learn from the environment, they learn from they predict certain trends and certain features they extract from the data, and in that process they learn from the data, and then they do prediction or classification or whatever task we are giving it to them. All right. So there are three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. That means that we can train machines using three different types. So in supervised learning, what we do is we train machine on labeled data. That means that we give machines the data and we also tell the machines what that data is. In unsupervised learning, we work with unlabeled data. That means that we can give any data to the machine and ask it to find trends in that data. And in the reinforcement learning, we teach the machine by rewards or penalties. Right. So I will explain this as we move ahead in our masterclass. But in reality, we learn it separately. Like we will learn supervised learning, unsupervised learning, and reinforcement learning separately. But in reality, if you see, there is kind of like a mix of all these three learning techniques if we want to make a machine learning system. Right. So supervised learning, unsupervised learning, and reinforcement learning, they kind of like coincide if we are designing some system which is learning, which is a machine learning system. So if I talk about like a self-driving car, so to design a self-driving car, I will give the self-driving car some data. That data will like a Google map or kind of like a navigation data, but I will also teach it with reinforcement learning, and I will also give I will also use supervised, unsupervised, and reinforcement learning, all three together. We will learn this separately, but we use it together in making machine learning models, right? So I will explain this as we go ahead one by one. So supervised, unsupervised, and reinforcement. If you have any doubts, any questions, you can ask me right now. We will jump right into the supervised learning, and we will do it with an example of a corn farmer. Right? Chitrans is asking me a question. Machine learning learns from data. So from where the lot data is gathered or where the data is coming. All right. So I will answer this question that all the data that we get is in the next class when we will be learning more about like data mastery. We will learn where the data is being collected and what are the methods to collect the data. Also later on in this masterclass, I explain why we need data and how we are collecting that. All right, so let's jump right into the first type of machine learning, which is supervised learning. And we will learn this supervised learning with a corn farmer's example, right? Okay, so let's say there is a farmer who wants to produce, who has a big farm like this, and he's producing corn from that farm. All right, so and he wants to train his system or a computer to predict how much corn is he producing in his farm, and how much of land that he should sow the corn in, how much of seeds that he should use, and how much fertilizer he should use to produce that corn. All right. So basically, he's trying to design a system where he's going to predict how much corn he will produce with the help of the data, that how much land does he has, or how much quantity of seed does he has, or how much fertilizer that he uses. Right. So what the farmer will do is the farmer will take this data, historical data, and he will kind of like, he or she will kind of like make a table where he's keeping this corn yield. That means how much corn is produced in one column, which looks like this, and how much fertilizer that he uses in other column. All right. So let's take an example that this year the farmer decides to use fertilizers, and he says that, okay, if I use this much fertilizer, how much yield of corn should I have? Okay, so he's kind of like helping, he's kind of like designing a machine to help him predict how much crop that he will have this year on the base of how much fertilizer that he will use this year. All right. So to do this supervised learning, machine learning, what the farmer will need is to collect the data. So that's the question that was there in the chat box. How will he collect the data? He will collect that data from history, that, okay, in for 1 year, for 141 kilogram of fertilizer he used, he got 7 ton of corn. Right. And in another year, he used 70 kilograms of fertilizer and he got 11 tons of corn. And in next year, he used 93 kgs of fertilizer and he got 10 tons of corn. Right. So he kind of like tracks this data manually, or there are other also options that we can track data or gather data from, and which we will learn later on in this process. All right. Now, what he needs to do is he needs to also label the data. That means that what is he predicting, or what is the output, basically. So the output is corn yield. That means that how much corn is produced. And what is the input? The input is how much fertilizer does he use. All right. So machine learning is basically mapping this relationship between data. So mapping X, that means that how much corn is sorry, this is wrong. So y should be the corn yield and x should be the fertilizer use. Okay, so I have made this PPT in a wrong way, but nonetheless, this should be y, this should be x. That means that we are predicting corn yield and based on how much fertilizer that we are using. So basically, by machine learning, he wants to find how much of the corn is being produced on the base of how much fertilizer has he used. All right. And in this process, he is not hard coding the system that if I use this much fertilizer, this much will be the corn, right? It is making a generalization of learning all these predictions from the data and trying to best predict the future outcomes based on the input. All right. So let's see if so what are the process, and the process of machine learning would be that he has a data. That means that we will call that a training set. The person is using this data to train the machine learning system or the agent or the computer, let's say. So we are in search of this learning algorithm. So basically, the machine learning is about finding this learning algorithm by which the computer will learn from the data to create a mapping. That means that we are creating this mapping of finding the output on the base of the input. If we give any input like fertilizer used, how much fertilizer is used, that's the input. We can predict this corn yield, which is the output of that. So this is the machine learning flow chart. That means that we start from a training set. That's the data that we will use. We will try to find an algorithm which will make our machines learn to give this mapping, which maps my input to the output. Okay, so basically in this example, we will take a data of corn yield. That means that how much corn is being produced on the base of how much fertilizer is being used. So in future, whenever we feed this machine learning system, that suppose I use 50 kg of fertilizer, the system will predict that this much tons of corn that you will produce by using 50 kilograms of fertilizer, right? Now, if we plot this data in a graph, it looks like this. So we have a data like this is the fertilizer used. How much fertilizer that we use is on this x-axis. And on y-axis, we have how much corn yield is there or how much corn that we produce. If we plot this data, then we see some pattern in this data. Okay, so there is a pattern in this data, and that pattern is what we need to find in order to do machine learning. So basically, we are training the computer or the system to find this pattern in data so that it can learn from the data and it can predict if there is predict the output at any point of the input, right? So if we plot some graph, like if I see that these are the data points that I have on how much corn is produced, on how much fertilizer is used, right? So I can see that a line can be represented by a line or a curve. That means that this data is somewhat in a linear way, or I can say that a curve also can fit this data. All right. So now machine learning in supervised learning. So let's talk about like supervised learning. So in supervised learning, what we do is we try to find a pattern in the data, and that pattern will best define my data in general. That means that we are trying to find a system which best defines my data in general, right? So we're trying to fit maybe a line or maybe a curve that best defines my data, all right? So the first algorithm or the first machine learning algorithm that we will learn today is linear regression, all right? And what linear regression is, if I talk about it simply, then we are trying to fit a line to estimate the output from our data. So basically our data is scattered like this, and we are trying to find a trend. So we see that our data is somewhat in a linear way. That means that it kinds of like grows linearly. So we try to find a line that fits this data perfectly. So we assume that there is a linear relationship between the variables. That means that these variables vary in a fashion that they depict a straight line. So we are trying to find this straight line which best fits the data. All right. And why are we finding this straight line that best fit the data? Because we are trying to make a system which predicts future outputs. So if I say that at 150 kilograms of fertilizer, what should be my corn yield? I will just project I will just use a pointer. So I'll just project wait. A line from here on this y-axis, and I can say that I will have 12.8 or 12.8 tons of corn yield if I have 150 kilograms of fertilizer used. All right. So I am making a generalized assumption. I'm making this this prediction by using this regression technique. That means that I'm trying to find a trend in this data, and I'm trying to fit a line that best describes this data. And in that process, I will predict any corn yield on the base of any input that I give it to it, right? All right. So how to do this? So if you are from maths, or if you are learning mathematics, or if you are into engineering, then you should know that the equation of a line looks like this, right? The equation of line is y is b naught plus b1x, where b naught is the y-intercept and b1 is the slope of the line, right? So basically, we are trying to find the equation of a line that fits this data. In linear regression, we try to identify the trends in this data by assuming that this data, this line is the best description of that data, or the best estimate of that data. Okay, so we are trying to find a line which fits this data, and the equation of line is like this, where y is b naught plus b1x, where b naught is, if I go to the next slide, so if you see here, so b naught is the intercept of this line on the y-axis, and b1 is the slope of this line. That means that how much this line is varying on the base of the input, right? The slope of the line, which is y2 minus y1 upon b2 minus b1, if I talk about in mathematical terms, right? So basically, we try to find these two parameters, b0 and b1, which best fits the data. Now, in our example, if I talk about b0 and b1, what they could be, and what these line will look like, is that my output y will be the corn yield. That means that which I am trying to predict, which will depend on these two parameters, b0 and b1, which are the b0 is being the y-intercept and b1 being the slope of the line, and this x will be the fertilizer used. Basically, I'm trying to predict a line which best fits this data, and I'm trying to find only two parameters, b0 and b1, which are the y-intercept and slope of the line. If I have the intercept and slope, I can draw a line normally, right? Now, the problem arises is how to find the best fit of the line. Like, I can draw a line like this. So I can say that this line fits my data perfectly. But how do I know that this is the best fit for my data, right? That's where the machine learning algorithms come. So if I talk about this, now, if I talk about this line, so this was the previous line, this gray line. If I can draw another line, that also I can say that that's also a best fit of my data, or another line like this, whether this is also a best fit of my data, or another line like this, that this is also a best fit of my data. So how should I choose which line fits my data perfectly, is what machine learning is about. So how can my computer learn to make an estimate of the data, or how can my computer learn to predict how my data is behaving, right? Is what I need to implement, or that algorithm I need to code. So I will not code in my computer that, okay, for this much fertilizer, this much corn yield is there. Okay, that's not a machine learning system, because if the computer sees some new data, then it will not understand or learn from that data. It will act as if it has a pre-fed information, right? But if I can make a system which can learn from the data, not hardcore programming it in a way, then how can it find this line which best fits the data, is what we are thinking about, right? I will stop for some time, and I will check my chat box for questions. If you are not understanding something, and if you have questions or doubts, please ask me right now. I'll be happy to help. For the next 5 minutes, I'll be answering your questions in the chat box. All right. Okay, so Akash is saying that y equals mx plus c. That's exactly what we are doing. So b naught is the intercept, which is c, and b1 is m, which is the slope. So Jay is saying that you have already done this in the last IBM ML internship. It is exactly the same. If you have attended my ML bootcamp, that's exactly the same that is being covered in this AL internship. So only the last two masterclasses are different. Everything else is the same. Pratik is saying that will we take out some time to ask queries? Yeah, please ask your questions here. Tushar is saying that we can estimate where the lines touch or nearby the most points. Exactly, this is where I'm going, and I will describe this in later sections. Anish is saying that using loss function, which I will explore in the next slides. Pratik is saying that the question is not very relevant, but it's about AI. What makes AI non-living? If we create an AGI, will it be alive like humans? If we finally create an AI that is alive, will we have to murder it to disintegrate it? Interesting questions about AI. I will take these questions by the end of this class. I will just copy these questions and take them when we end this master machine learning class. Very relevant. It's not irrelevant. We will start the practical coding section. Amir is asking when we will start at 5 p.m. sharp. What is regression? Someone is asking. So regression is basically Divyansh is asking the way of attendance. So regression is basically trying to predict, trying to fit the data in certain pattern, and we can do it by fitting it in a linear way or in so basically trying to find the trends in the data. So if I see that these points are behaving in a fashion that it is in a linear relationship, then we will kind of like call it a linear regression, right? Um, uh, Ashrit is asking about dependent and independent variables. That means that dependent variables are basically which depend on some other variable. Suppose here corn yield is depending on how much fertilizer that we are using. So X will be independent variable because how much fertilizer do we use does not depend on any other variable. This Y corn yield will be a dependent variable. That means that we are depending on X to predict that. All right. So basically, dependent variables are output variables. If I say it in a simple language, independent variables are input variables. Okay. What are some techniques to improve performance of supervised learning models? So we can do optimization. There are certain optimization techniques that we can use to improve. We can also do a filtration of the data. That means that we can use a proper data to train our model that will improve the performance of supervised learning models. Basically, the core idea is to minimize the error, which I'm going to explain in the classes ahead. If you are new to AI and ML, yes, also you can learn with these sessions. Just be more focused and more attentive in these classes. I will be happy to help if you are stuck anywhere. All right. I'll be teaching how to code this. Yes, MMI is asking, will I be teaching to code? All right. How do we know which technique should be used, like regression, logistic regression? So I will cover this in all the master classes that we have ahead. All right. Vicky is asking what is overfitting. Overfitting is basically if we are trying to fit all the points in our data. That means that we are not learning from the data, but we are trying to map each point in input to each point in output. Right? We'll be using Python to code this. Danesh is asking, and thank you so much for asking these questions. These are very, very interesting questions. I will not be able to answer all the 900 participants that are there in this masterclass to answer all the questions, but I will answer only the relevant questions that are there. All right. Okay, so some people are asking why linear regression. That means that why we are doing this linear regression. So I will be covering linear regression in our class right now. Tomorrow we'll be learning about multiple linear regression, polynomial linear regression, and then we will move on to decision trees. Then we will move on to different other algorithms also in machine learning. So today's masterclass is about linear regression. We are talking about how we are seeing the data which is there in a linear fashion, and how we are trying to fit a line that best fits the data. All right. So basically our problem right now is we can draw many lines to fit this data, right? So which line is the perfect fit, or which line best fits the data, is what we need to think about. So how we will do that? So what we will do is, I'll erase everything. All right. So the key idea behind machine learning algorithm, or if you talk about the key idea behind AI or machine learning, is to minimize the error in the expected behavior of the machine and the actual behavior of the machine. So if I talk about the autonomous driving car, so the idea of designing an autonomous driving car uh, is to minimize the error uh, between what the car will do without any guidance or what we expect it to do. So suppose if I ask if we want our car to like move in a way that it does not hit our other vehicles, or it reaches from a point A to point B, that's the expected behavior. But what if the car hits a vehicle? That will be an error. So our idea of machine learning is to learn from all the data and reduce the error as less as possible. So we try to like perfect the system in a way to behave in a perfect, right? So similar thing we will do is that we will find this error. So we will see that if we try to like fit a line like this, then if this was the actual output, in the line the predicted output will be this, right? And the difference between the actual output and the predicted output will be my error, right? So in all of these data points, so starting from this first data point, my predicted output will be this line, right? This will be my predicted output, and this will be the error. In this will be the error. In this will be the error. In this will be the error, right? So for all the data points, I will find this error of actual output, which is y1 hat. So, and minus the output, which is expected output, which is the actual output, which is yi. So we try to find this error, right? And we take this error function. So we can also call this loss function. Some people also call this cost function, but for this class, we'll call this an error function. So we take this error function, which is the difference between the predicted output and the actual output, and we try to minimize this over all the data points. Okay, so we try to minimize this over all the data points. And if the distance between the actual output and the predicted output is less, that means that that line is the best fit for our data. All right. So basically, we are trying to minimize to make a system which has a efficiency uh, which is the maximum. All right. So we're trying to minimize the error so that our system is as near to being perfect. It will not be perfect because it will not. All these relationships are not in a single line, but this will be the best fit or best learning for our machine if we can minimize this error in the predicted output and the actual output, right? Now, how to minimize that error? All right. So uh, we take the sum of all the error. That means that we take an error function, which is the sum of all the errors of the predicted output minus the actual output, and we try to minimize this sum of the error. Okay. One way is one. There can be different ways of using or defining the error function. So one way is to use the ordinary least square method. So to avoid the confusion, when I do this summation of errors of actual minus the predicted output, so in some sense I also have these negative values, right? This will be negative, this will be positive. So these positives and negatives, they cancel out each other. But it should not happen, because error is not negative or positive, it is the error, right? So one way is to use this ordinary least square method. That means that we square the error to remove this negative and positive canceling, right? So we square this error and we try to minimize this square of the error. That is called ordinary least square. All right, and we try to find the algorithm to find B naught and B1, that were our parameters, right? So B naught was the intercept here, B naught, and the slope of the line, which is B1, and we try to find B naught and B1 to find that line which will best fit the data, right? So basically we are minimizing this error. So our algorithm will be to minimize this error. And while we are minimizing this error, we will find B naught and B1 values. So for B naught and B1 values, we will try to find the least error. So if we try to find the least error, those values of B naught and B1 will be my parameters. And I can draw a line which is the best fit for this data. All right. Now, the algorithm that we use is called gradient descent. So the gradient descent algorithm is, I will not be able to explain the whole mathematics behind that, but let's understand the intuition behind what is gradient descent and how we can use that. So basically, we are trying to find these parameters, B naught and B1, in which the error is the minimum. Okay, so basically if I draw the graph between this error function, error of B, which is the square of the actual predicted output minus the actual output, and this is how my error function looks like in three-dimensional space. Okay, so on the base of B naught and B1. So if I start at some point, any point of values of B naught and B1, so my B naught value at this point is 0.5, and my B1 value at this point is, suppose, say 0.2. All right, so I start at this point and I choose an algorithm that makes my error minimum. So I start at this point and I look where I need to go and I go in that direction. So I find the values of B naught and B1 to go in a direction where the error is minimizing. So I go in this way and I reach this point, and then I go in this direction and I reach this point, and then I go in another direction and I reach this point. I will keep doing that until I find this minima of error in my graph. All right. So basically what I'm doing is I am finding these values of B naught and B1 so that I am minimizing this error. All right. So this error, what I do is I take the derivative of this error function and I try to find the minima of this error. All right. So the minima of a derivative function. So the equation looks like this, like the parameters bi, the parameter vector will be the original parameters B naught and B1. I decrease these parameters by a factor alpha, which is called the learning rate. That means that how much should I jump from a point in the space to another point, and the derivative of the error function, so that I can find the minima of this graph. All right. So we can see like three-dimensional pictures are more difficult to understand. We'll learn better from a two-dimensional picture. So if it is my graph, like the y equal to x squares graph looks like this. So if this is my graph, then this is the minimum in my graph. And I start from any random point of of my values B naught and B1, and I move in this direction. That means I subtract this error. This is my error function, and I take the derivative of this error where the slope is going, and I see that the slope is going in this direction. So I will move in this direction, and I will reach here, and then I will reach here. I will decrease the value of B, decrease or increase the value of B, so that I find the minimum in this graph. All right. You can find about gradient descent. I will not be able to cover this in a 2-hour lecture with hands-on activities, but you can find more more simple videos on what gradient descent is and what that algorithm is and why we are trying to use gradient descent to minimize our error in YouTube or some other channels. All right. But basically, we are trying to basically minimize the error so that we can find those two perfect parameters B0 and B1 that best fits my line. Right. That's the core of whatever AI system uses machine learning. So basically, we are trying to predict the error in to minimize the error in our prediction. And by minimizing that error, we are perfecting our system. All right, let's get back to our example. And we see that once we find the best values of B0 and B1, so we find that at these two values of B0 and B1, that means that at this intercept and this slope, our line best fits the data. That means the error is minimum. So if the error is minimum, that means that is the perfect trend that our data is going with, right? So we will have our linear regression model. So our linear regression model will be having the best values of B0 and B1. So we are trying to predict our line. We are trying to find these two best values, B0 and B1, so that the predicted output has the least error. And if our predicted output will have least error, that would be the best machine learning system. All right. Now let's get ahead in how we can design our own machine learning system. Machine learning system, we are talking about machine learning system. Now, how to design that? What are the steps? What are the 5 different types of things that we will require to do when we design a machine learning system, right? Okay, so we will start from step 1, which is to get the data. We saw from the farmer example, right? So farmer was getting this data. He was making a table where there was some values of corn yield and how much fertilizer used, right? So we will need data to train our system with. So we'll get the data. Second is to clean, prepare, and manipulate data. Our data might not be clean, right? It might have some missing values. It also might have some repetitions. So we need to clean, prepare, and manipulate the data. We will learn it tomorrow in tomorrow's masterclass, how we can do that. And then we will train the model. So we will find an algorithm to train the model, and we will test our model. That means that after training model, we will have a machine learning model, which we will test our machine learning model with some data. So we have the data, we trained our machine learning model, we found that line that best fits the data. Now we will give more data points to find if our machine learning model is working perfectly or not, right? So we will test it and we will improve it. If our machine learning model is not up to the mark, we will either put more data, we will either clean the data, or we will try to use different algorithm to train our model so that our machine learning model is perfect. All right. So how to get the data, right? What are the ways to get the data? So for any machine learning problem or designing any machine learning system, we need to first identify the problem that we are solving with machine learning, right? The farmer, if we take the farmer example, so farmer is trying to identify how much corn that he will produce on how much fertilizer he will use, right? So we need to define the problem that we are solving. Once we define the problem, we know what are our data requirements, whether we want the data in a structured way, whether we want it in an unstructured way, what are the specific variables, right? What do we need to make this machine learning system, right? In this example, farmers examples, we need how much corn is being produced, how much fertilizer is being used. So which variables do I need to fit in the columns? That data requirement we will define, right? What are the constraints? What are the variables? We define all that. and then we collect the data. Now we can collect the data by web scraping. So if you are designing a natural language processing system, so when you are training a machine to understand language, then what we do is we take all the written text that is in the internet by scraping that from internet by using web crawlers, and we keep that in a data file, and we use that data. Or by using APIs, or by using database survey, you can also do a survey, or you can also collect the data from a sensor, or you can even input manual data in the system. But you need data to train your machine learning, right? Once you have a data with you, you will split the data into training data and test data. So basically, machine learning model, you have a data set, you need to keep some data for training to find trends. So like in the example, these are some data points. I will keep some of the data to find this line, and this line I will test using some of the data that I have. So suppose I have 3 points, and the same line I will test my line on these three points, whether it is behaving same to my training data or not. All right. So basically, the whatever data we have, 90% of the data we use it for training. From that data, our model extracts some patterns and features and makes the prediction. So basically, we are predicting this line which best fits our data, right? And we will keep 10% of the data to test the prediction, all right, whether it is working fine or not, or how much error is there. Why we don't use 100% of the data is that if we use 100% of the data, then the model will not be ready to learn from the new data that is there, right? Or we will not be able to also determine whether the model is working fine or not. When we will do the hands-on activity, when we will actually code this machine learning system, we will see what is the use of splitting it into training and test data. But for now, we will whatever data we have, we will keep some data for training. That means that with that data, we will find that prediction, and we will keep some data for testing. That means that we will use that data to see whether our prediction model is working fine or not. Okay. Let's move ahead. All right. So today's hands-on activity, or what we are designing, is we are going to design a salary prediction model using simple linear regression. All right. So we are going to design a system which can predict the salary of an employee in a company on the base of the number of years that he has worked in the company. All right. So let's define the problem. So the problem is we are developing a machine learning model. We are going to predict the employee salary by using years of experience to help HR make fair, competitive compensation decision based on historical data. So basically, let's say you become a machine learning engineer and you go to a company, and the company says that the HR is very is very he has a lot of work because the kind of like employee salary prediction. I'm sorry, they are hiring a new employee, or the employee are being promoted. So the HR is in very much pressure. How much salary should he offer to the person who is joining new, or to a person who is being promoted? So he calls you to his cabin, and he says that, you are the data engineer. I need you to design a system which predicts the salary of an employee, how much years of experience that he has in the company, and how much salary that person should have, so that I can make a fair decision that, okay, I should offer that person this much salary. All right. So the company can have like more than 200 employees, and for those 200 employees, if HR sits individually to define the promoted salary, then the HR would be in so much pressure to make those decisions, right? So he calls you up and he says that, okay, you are the person, you are a data expert, this is the historical data, and based on this data, make a system to predict the salary of an employee based on how much years of experience does he have. All right. So that's the problem that we are having, that we are going to solve today, and we are going to code this in Python. If you don't know Python, no worries. I will explain it in very, very simple language. We'll be doing it in Google Colab. I will be sharing all the links to all the files that we will use in a while. But before that, let's define the problem. So the problem is this, that our HR is very much stressed. He has to promote some employees, but he doesn't understand how much salary that he wants to give to those employees. So he calls you, he asks you to design a system which can predict the salary of the employee based on how much years of experience that he has in the company, right? So in company, generally the salary increases with the number of years you have worked in the company, right? So we'll use this data set of salary data with respect to the number of years of experience in the company. So now you go to the HR. The HR, what it did was he historically collected all this data. So he has these years of experience in one column, salary in other column. Remember that we are doing supervised learning. Okay, that means that we are learning from this label data. So on one column, we have this years of experience. On one column, we have the salary of the employee. Now we need to define a system which predicts that, okay, if a person has 7 years of experience in the company, how much salary should we give to that person, right? So to do this with machine learning, we will design a machine learning model to predict what is the salary of that person, right? So the data set we have is a data set of 36 employees. So 36 employees in the company, and they have these years of experience, and this is the salary of that person. First column is the years of experience, and second column is the salary of the employees. Okay, so this is the salary, this is the years of experience, and we try to find what is the pattern in this data and design a machine learning model to predict the salary of that person. All right. The second step will be the defining the data labels. So defining the independent variable, that means that the variable which is the input that we will give, and the dependent variable, which is the output. Okay, so independent variable input will be the number of years of experience. That means how much years of experience that person has, and output will be the salary of that person. All right. So dependent variable here in this case will be salary, and independent variable will be numbers of years of experience. All right. Okay, so if I plot this graph, I saw that this is the years of experience, so ranging from 0 to 14, and this is the salary of the employee from 30,000 to 1,40,000. Okay, so I see that this data has a kind of like a linear pattern, right? I can see that this data moves. Sorry, I'm not being able to draw a straight line, but if I try, then yeah, okay. Basically, like my idea is to show that it varies in a linear fashion. So now, as a machine learning engineer, you say that, oh, this data is varying in a linear fashion, so we can design a linear regression model to find a best fit line to predict the salary of that employee, right? So in this data set, X is the years of experience, which is on this X-axis. Y is the salary of the person, which is in the Y-axis. And we are finding a relationship between X and Y. So a mapping, basically, we are finding where X maps to Y, right? All right, so we will use this data set from Kaggle. So Kaggle is a library of data sets where we can like there are many people who have put lots of database and lots of models in Kaggle itself. So this is a huge library of a lot of data sets. So what I will request you to do now is you will open your own browser. Let's do a hands-on. So we will open our new browser. Let's say this is the browser. So what we'll do is we'll go to a new tab and type Kaggle. Okay. And in Kaggle, if you click Kaggle, then you will see a web page like this. All right. So I will give you this link of the database directly so that you don't have to search it again. So let me just copy this from the PPT, and this is the link. All right, so I'll paste the link in the chat box. Those who could not understand gradient descent, I will explain it in the end. All right. So this is the data set that you have. I have pasted the link in the chat box, meeting group chat. Wait. Please use that link from there to go to the data set. So I will use this to go to the data set. So this is what it will look like. Some of you might have to log in to download this. So if I just download this and download via Kaggle Hub. Yeah. Wait. As zip. So I will download it as zip, and it will ask me to log in. So I will sign in with Google, and I will use my account to sign in and continue. And it will ask my name. Username is already taken, so I will use 2503 and next. It will give me some privacy steps, and then I agree. And it will take me to this page where I can now download it as zip file. Okay, so once I download it as zip, it will show me like this. All right, so what you need to do is you need to go to the link that is there in the chat box. For people who have logged in from YouTube, those who are live on YouTube, if I can tell, just go to Kaggle, and I think you need to type RSADIQ, and this salary data set, you can take it from there. Okay, so those who have logged in from Google or YouTube, RSADIQ in Kaggle, type and go to this salary data set, and you can download this from there. Okay, so once you click on download it as zip file. All right, so you'll see this zip file here. So you can go to the zip file. It looks like this, and here is your data set, which will look like this. All right, so I can also paste this data set in the comments so that all of you can download it from the chat box also. If I can just extract this. All right, so I will send this file to all of you, the salary.csv file. You can do this, you can use this salary file to you can download this salary file from the chat box also. Okay, so this data set file, you can download it from the chat box. It looks like this. Let me just go quickly. Looks like this, where on one column you have years of experience, and on other column you have salary. So this is a file for 36 employees. On one hand we have this years of experience, and one hand we have salary, right? Kranti is asking, can we use mobile for this hands-on session? I'm not sure if you can use mobile for this hands-on session, because it will require coding. It will be difficult for you to switch in between different things. So you can use mobile for watching this lecture, and then can code on laptops. All right, so if you have the data set, please type in on the chat box yes or done if you have the data set with you. Thank you so much, Priyanshu, Vishnu, Thank you so much. If you have a data set, some people are asking me to send a data set again. Thank you so much, those who are replying yes or done, because that is you're helping me and the other students also to set up the pace for this. One more time for everyone, if the data set is not there, then I am uploading it on the group chat. Okay, so to everyone in the meeting, I have sent the salary.csv file, so you can download this from there. I will also paste the link one more time if you want to download it again. All right, so that will be always there in the meeting chat box. You can download the salary file, and the link is there for you to download also. All right, now we have the data. That means that we are already at the first stage. Now we can make our machine learning model, right? So our the person who is the HR, he has called us. He said that, okay, this is the data. Now you have the data, and now you need to make the machine learning model to predict the salary of that employee. So that means that how much salary a person will get on how much years of experience that he has in the company. All right. Now I will go back to my slides to share with you the template that we will use. So I will paste this link on the chat box again. So I have pasted the link on the chat box. So what we'll do is we will use Google Colab to design our machine learning model. So this is a QR code, or this is a link from where you can go to Google Colab, and it will look like this. Okay. So once you go to this link, you will go to Google Colab. So for designing our machine learning model, we will use Google Colab, and Google Colab is kind of like an integrated development environment, which is online, where you can code on Python. Not only code on Python, you can also write your notes. It acts like a notepad where you can write your notes, write your code, execute all these codes in different code blocks, so that you don't have confusion between where your code is like. You can also do this in Jupyter Notebooks. Yes, Aryan Kumar is saying, but for Jupyter Notebooks, you will not have the template. So I request you to do it on Google Colab, because that's free also. And it also gives you more GPU and CPU power. And also it will be staying there wherever you go. So suppose you have a file which you want to do it in another computer, then you can always access it from the cloud. So it's more handy in this case. All right. Thank you so much, Anshul, for suggesting that. And let's go to meeting group chat. Again, I'm pasting this link. It is there. You can download the data and also go to Google Colab. If you are at Google Colab, then say yes or done. If you are seeing the same page that I'm seeing. Thank you so much, Shubham, Tushar, Nitin, Trishala, Mehak, Kranti. Thank you so much, Deepti. I cannot take anyone's name, but I'm really grateful to all of you, those who are saying yes or done in the chat box. That helps me set the tone of the class and set the pace of the class. All right, so are you excited to code? I am really excited to code. So let's start coding. I will stop. I'll give more bandwidth to this. So let me just optimize some things. Let me close everything. Let me also close my camera so that more focus is now on this and executing this. All right. So this is the simple linear regression technique. This is the template that I have made, and I will explain the code step by step. That means that we are designing this system. We are trying to find this line that can best predict the data. So we have a problem that HR has called us to design a salary prediction system on the base of how much years of experience that person has. So we are designing that in Python. So we go to our Google Colab. We said that, okay, boss, we will do this. We will go to Google Colab, and we will use this template. So this template is nothing but a step-by-step process. But you will not be able to um, change this template because this is a read-only file. So what you will do is you will go to File and you will save a copy in Drive. Okay, so you will save a copy in Drive. You will make a copy because this is a non-readable file. Okay, so you save a copy in Drive, and you will see that you will make a copy and you rename this copy as your name. Okay, so to change this, you will rename this as your name, Amit underscore simple linear regression template. Okay, so the steps are to make a copy, save a copy in Drive, and make a copy and rename it with your name. All right, so if you have made a copy and renamed it, then please say yes or done in the chat box so that I know that you are at the right place. All right, Aditi has done, Mohit, Druhi, Yash, Tanmay, Vicky, Kriti, thank you so much. All the people who are setting up pace for this class. I'm really, really grateful to the people who are replying on the chat box. Thank you so much. All right, so just rename it with your name. Let's do the first thing now. If you have renamed it and you have saved a copy, because if you do something in here, like if you do anything, like let me just import this library like NumPy as NP, and I run this, it says that this is not authored by Google, it is my file, so you will not be able to change, right? So you will have to do the, you will have to make the copy of this. So how to make the copy is you go to File and save a copy in Drive, and it will automatically make a copy, and it will take you to that copy. And here you need to rename it. To rename it, you go here, like on the top of the name, which is here, and just delete the copy of and rename it. Okay. All right, so let's do it now. I have renamed it as my own name, Amit, and we will import the libraries. So the first step in any Python program. So now we are coding in Python and we are coding this machine learning in Python. The first step in any Python program is to use these libraries that people have already made. So we will not reinvent the wheel again and again. That means that we will not reinvent gradient descent. We will not reinvent defining variables. We will not reinvent learning, taking extracting from data. We will use what scientists and researchers have already done. So we will use these libraries, and there are functions which we will use to do machine learning. All right, so we will not reinvent everything. That means that we are not hard coding everything. We are using these libraries which people have already made to do certain tasks. All right, so if you are very new to programming, if I talk about like the libraries, then they are collection of functions and variables which we can use to do certain tasks. All right, so some people are saying that they are not understanding how to copy the file. So to copy the file, you go to File and you save a copy in Drive, and from there the copy will be made, right? Some people are asking for link. The link to the Google Colab is this. I pasted it one more time in the meeting group chat. Okay, now, so let's import some libraries. We will use some predefined libraries, and these libraries we will import first. So the first library that we will use is, we will import. Someone is asking, is Python prerequisite is needed? No, you don't need to have any Python prerequisite. Everything that you need to learn about Python, I will explain it here. Okay. So basically you are giving some instructions. So first instruction you will give is you will import this library called NumPy. Okay. And NumPy is a library used for working with arrays and data. And because we are working with data and we will be working with arrays, we will import this library called numpy. And we are not importing numpy just like that. We are also keeping a shortcut. So importing numpy as np, we are giving it a name so that we don't have to call numpy again. We can just call np, and that will be our that way we will use this numpy library. All right, so first library we will use is numpy, which is numpy as np. Second library we will use is import matplotlib, and from matplotlib, we will import pyplot, and we will import it as plt. Okay, so that's the generic way of importing it. So first is we are importing numpy. We are importing numpy as np. Why we are importing this? To work with arrays. Okay, I am using this hashtag to type a comment here. Okay, so you don't need to type this. So import numpy as np. Why? To work with arrays. And import this matplotlib matrix plotting library. And from there we are importing this pyplot library as plt. Okay, why? This will to plot the data in graphs. So, or to visualize the data. Okay, so we are importing this matplotlib library dot pyplot. Some scientist, some researcher has made this library where you can use simple functions to create graphs, charts, and all. Right, so we are using this to import these two libraries. All right, now we will import this third library, which is pandas as PD. So pandas library is to use data sets. So it will read from the data, it will work from the data. So to work with data, we will use this pandas library. Okay, so three libraries will import. Import numpy as np, import matplotlib.pyplot as plt, import pandas as pd. Okay. Kunjam is asking, can we also use Visual Studio Code? We can use Visual Studio Code, but I request you to use this Google Colab because I have made this template. This is a step-by-step guide. So it says that import the libraries first, import the data set, then split the data set, train the data set. So it has all these, step-by-step learning. And also, whenever we do some work, if we can organize it step-by-step way, then we can always use it again and again, right? So I already have made this library, this template for you so that you can use it again. And I am not suggesting you to use Jupyter Notebook or Visual Studio Code because later on when we will do advanced machine learning, I will require some of your code to be copy pasted from these libraries that we are learning in other master classes. So to have all these files in one place would be a better idea. Okay. Some people are also asking about what about Kaggle? You can use Kaggle. You can use any IDE that is best for you, but I suggest let's do it in Google Colab for this time. And then maybe when we are expert, you can use any of the library, any of the IDEs that you want to use. All right. So what we did is we had a data and we will import the libraries first. That's the first step. That means that we are using these repositories or libraries of the people who have already researched about all of this, and we are using that to design our machine learning model. That means that we are not reinventing the wheel again and again. All right, so we are importing this first library numpy, second library matplotlib.pyplot, third library pandas.pd. If you have imported this, then press this play button here to execute this code. Okay, so this is a code that we are here. So when you go to this importing library, you can select code or text, and you just run this code. Once you run this code, it will be executed. Okay. Someone is saying that run button is not displaying because you chose text. ठीक है, तो टेक्स्ट अगर आप चूज करोगे तो रन बटन नहीं आएगा, आपको कोड चूज करना है. Okay, so delete that, go to code. Okay, code, and that run button will be there. Okay. Yeah, thank you. All right. So These three, if you have done that, paste done or yes in the chat box so that I can know that we are at the right place. Thank you so much, those who are doing it. Thank you so much, Tushar, Revant, Anantan, Ritika, Ashwin, Abhishek, Dhruv. You are setting up the pace for the class. That means that whatever I'm doing, you are also doing. If you are not, if you're falling behind, if you are having any problem, then also let me know. Two things I will share one more time after all of you are saying done is in the dataset and the file, so that the people who lagged behind also have the access. Okay. So I sent the salary.csv file again for the people who have joined in late, and for people who do not have this Google Colab, I have sent a link. Okay. Now, so this run says that I have if you get a green tick here, that means that you have imported these three files successfully. If you get a error, then you will see that these three files have not been imported successfully. Right? There is no output to this. So output we will have here. Okay, so we have a lot of steps to do. We are doing it step by step. Okay, so output will be only the green check here. That means that you have imported all the libraries right now. You imported NumPy library. That means that you are ready to work with arrays. You imported this matplotlib library. That means that you are ready to plot graphs. You have imported this pandas library. That means that you are ready to work with data. And you have created shortcuts to use these libraries. Now, the second important thing is now we have the libraries to work with. We need the data to work with, right? Okay, so we have the data. We need to import that data into a data set. So what we will do is take this step very carefully. What we need to do is we need to go to this folder option here. Okay, this folder option. And this upload option is there. So you upload and go to the dataset file, wherever it is. For me, it is here. That salary file. And a warning will be there, but you ignore that warning. And you upload your dataset. Okay. So one more time, the steps is you import the dataset. So you need to have the dataset in the runtime environment only. So you need to have the dataset here. The Google Colab will not take dataset from your computer. So it needs to have in the server itself. So you go to this folder option, you import, you upload the file wherever your salary file is, and you upload it here. So you should see a salary.csv file here. Okay. Now, let's import this dataset into our Python code. Okay. So we will use a variable. Let's create a variable called dataset. And we use this pandas. So pandas is an amazing library which we can use to read, manipulate, and work with data. So we will use this pandas library, pd. We made a shortcut. So pd dot, and we want to read this file, right? Salary.csv file. So we will use this function read underscore csv, and in the brackets, we will name this function, this file, right? Which file do we need to read? Salary.csv. Okay. Salary.csv. So we made a variable dataset. That means that we are from this CSV file, we are importing all the data into our code now. Okay. So we are reading it with pandas library, which has this read CSV function. And from this read CSV function, we are reading this salary.csv file, and we are reading all of that and creating a dictionary inside my dataset variable. Okay, now this data set is actually carrying all the information that is there in this file. Okay. So basically we are reading the CSV file and saving it to a data set variable. Okay. Now, once we read this file, Now what we need to do is we need to specify our independent variable, okay, x, right, which we will use to predict y. The x in our case is the numbers of years of experience, right? So on the base of how much number of experience, how much salary is there. So x is the number of experience, y is the salary, right? So we need to define x. All right, so let's do it. X is, so data set dot, so we'll take this data set variable which has all of our data, and from this data I will locate where my x is. Okay, I will see where my x is. So here my x is in first column, right? All the rows of my first column is x, right? First column and all the rows are my x, which is the years of experience. So now what I will do is I will locate that. So for locating, I will use this function iloc. Okay, iloc, and now I will pass on arguments. So here I take all the rows. So start of the row to end of the row. So start of the row is say 0 and end of the row is 36. So I can do this also. So like start of the row to end of the row. For the first part of this, I need to define the row where my data is. Okay. So on from 0th row to 36th row. But I need all the rows, so I will keep it empty. Okay. So if I keep it empty, it takes all rows. I can also define which rows it should take, but if I keep this empty, it takes all rows. Okay. This is for people who don't understand Python. For people who understand Python, it will be easier to understand. Okay. Now for columns, I just need to have the first column. Okay. Now in Python, indexing starts from 0. So this is 0th column. This is first column. Okay. So here I just need 0, right? All rows and 0th column is where my x is. Okay. And from this, I will take all the values. So I take all the values located in all the rows and first column, and I put this in x. Okay. Now I make another variable, which is y, and I take dataset.iloc all the values of x, which column? First column dot values. Okay. This first column, 0th column, and first column. So all the values in the first column, and I take it as values. Okay. So now I have my x, I have my y. Okay. Now let's print that. If I have my x and y, just run this cell and let me check. Print x. X is this, all the values in the first column, and if I print y, then it has all the rows in my second column. Okay. Now why 0 and 1? Because in Python the indexing starts from 0. So first column will be 0th column and second column will be the first column. Okay, n-1 indexing in Python. So now I printed x and I printed y. I see that I'm happy with the result, that for first column I have my years of experience. For second column I have y, which is the salary of the employees. Okay. Now I want to make this general. Okay. Here don't get confused. Why I am doing this step is to make it general for all the data sets that we will use. Okay. So if you have done this, please say done and yes in the chat box so that I can move ahead. Right. Thank you so much. Thank you so much. Those who are saying yes or done in the chat box. Aditi is saying, please wait. I'm waiting. For those who are having errors, some common errors, one common error, it will remove most of the people's error is some people might have just typed small s here. Okay. So if you have typed small s, that's not the file. The file names with capital S. Okay. So if you are having an error that salary.csv not found, then it can remove the error, capital S. All right. And if the people have error that data set not found, they need to upload this. To upload this, they need to go to this folder. They need to go to this upload option, the salary file, and here. Okay. Upload option, salary.csv file, and you open that. Okay. So if you want this file again, those who are asking me कि आपको सैलरी वाला फाइल कहाँ से मिला, वो मैं आपको भेज देता हूँ. ठीक है, ग्रुप चैट में आई हैव सेंट इट. ठीक है, फोन में थोड़ा मुश्किल है. गरिमी इज आस्किंग इज इट पॉसिबल, बट फिर भी ट्राई करो. हो तो जाना चाहिए गूगल कोलैब में. ठीक है, ओके चलो. अभी नाउ लेट्स, इफ यू आर डन, लेट्स make this generic. ठीक है, generic that means that we can use it with any data set. ठीक है, so right now my x is in 0th column, right? My x is in 0th column. What if my x was not just years of experience but also his qualification? What if there were 3 columns: years of experience, qualification, and salary, right? My x would be 2 variables then: years of experience and qualification, right? Years of experience और qualification के बेस पे मुझे salary predict करना है, right? In that case, generally my x variable is from 0th column to the last column. Okay, from 0th column to the last column. Now in Python, लास्ट कॉलम से जो इंडेक्सिंग शुरू होती है वो माइनस में होती है. सो -1, -2, -3, so on. So if the last column was this, that would be -1, -2, -3, -4, -5, -6, and the indexing starts like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so all of my dependent variable जो भी मुझे predict करना है output will be on my last column. Okay, so I need my Python, my dependent variable, which is x, to take all the rows, all the columns except the last column, right? To the last column. So last column will start from -1. So I will not include -1, but I will start from 0 to -1th column, and I take all the values there. Okay, so I make this generic for any data set that I have. So I'm making this template generic to use with any data set. मुझे ये भी change करने का जरूरत नहीं पड़ेगा. Next time when I use this file, I will use it as it is. I will just change some of things here. बाकी मैं कुछ भी change नहीं करूंगा. Okay, so I'm making this generic by taking it from 0th column to the last column, and last column is -1 because the indexing from last column starts in Python by -1. Okay, similarly here, instead of 1, I just need the last column, right? So I start from last column and I take all the columns after that. So I can do something like this also, but that doesn't make any sense because from last column to last column. So I remove this. So always the last column will be my y. So last column is -1. So I take this salary, I take this output as -1. So we will change our code to make it generic to work with any type of data. Okay, one more time I'm explaining. So x is the independent variable. That means that the variable on which we will predict y. So we take all the values of the rows, all the values of column till the last column. Okay, and y is the data set. Y is the dependent variable. That means that it depends on x. So I take all the values of rows and only the last column, because in any data set I will keep my output in the last column. Okay, generally it is kind of like a norm to keep the output in the last column. All right, now I will run this code. Okay, once I run this, my output of this print will not change. Okay, see, same output, है x also same, y also same. Okay, so if you have changed this, to make it generic, then please say done or yes in the chat box. Thank you so much, Shubham, Mohit, Nitin, Lahari, Suryansh. Thank you so much, all of you, those who are saying done and yes. Some are asking me the Google Colab link. एक बार फिर से मीटिंग ग्रुप चैट में गूगल कोलैब लिंक पेस्ट कर देता हूं and you can use that collab. Okay, चलो. ये print वाले I remove because these are not needed. Okay, if you have that, just keep it with you. I am removing it because so that you can see the whole code. Those who are still doing this, they can also do the whole code. Okay, now let's do the third step. So remember, मैं जब machine learning की बात कर रहा था, then we had these steps of machine learning, है ना? So we got the data, we imported the data, we have made the independent variable. This we will learn tomorrow, like how to clean the data for machine learning. But let's come to the third phase, which is training the model. But before training, we need to split the data into training and test data. That means that we need to keep some data for training and some data for test, right? So let's do that. We were here. So let's split the data set into training set and test set. Okay, so we'll open a new code block. Now we will use an amazing library called scikit-learn. So scikit-learn is a library which you can use to do any machine learning algorithm. Okay, so remember this library name, which is scikit-learn, which you can use to do any machine learning algorithm. So it's an amazing library, and by amazing, that means that it has everything you need for machine learning. So I will introduce you to scikit-learn. So go to Google and type scikit-learn, and scikit-learn, scikitlearn. Okay, scikit kitlearn, learn, scikit-learn. So you go to the scikit-learn library, and here you can see whatever you can do: classification, regression, clustering, model selection, dimensionality reduction, pre-processing, all of these things, whatever is there in machine learning, you can do with this scikit-learn library. And I could have told you which tool to use from scikit-learn, but I want you to explore this scikit-learn library so that you can do all these things by yourself. Suppose I am not there to teach tomorrow because maybe I'm busy with some other sessions. You can also use scikit-learn to design your own programming system. That's why I don't want you to spoon food with everything. Okay, so go to scikit-learn library, which looks like this. We will search train test split. Okay, train test split here, because we are splitting this data to training and test sets. Okay, maybe if we search the function itself, train test split. Okay, so if we type train test split, train underscore test underscore split, we will see that from model selection, we can use this train test split method. Okay, this function train test split, self-explanatory. It splits the data set into training and test sets. It also tells you, it also teaches you how to use this by examples. So it says that if you type this from scikit-learn.model selection, import train test split, then you can use this train test split function. All right, so we will do this. So we will go back to our code and we will type from scikit-learn, sklearn, and we will see what was there in scikit-learn. From sklearn.model selection, model selection is the library from scikit-learn. We will import this train test split function. Okay, from scikit-learn.model, how is it written? Underscore selection, import train underscore test underscore split. Okay, so from scikit-learn.model selection, import train test split. So we'll use this train test split to split our data into training set and test set. Okay, so let's make the training and test set variables. So let's call our input training data is xtrain and xtest and ytrain and ytest. Okay, and we will use this function train test split to split this data, okay, into sorry, I said test, it's train test. Okay, train test split to split this into training set and test set. Okay, now this function takes some arguments. Okay, you can also check this in the scikit-learn library, that what arguments does it take. So it takes x and y, what are our dependent and independent variable, what is the test size, how much should our test data be, what is the random state. I will explain what is the random state in a while. Okay, so here you explain what is the x is x, right? Small x, huh? We have used small x, and y is y. Okay, so from this x here, take split this x into x train and x test, and this y into y train and y test, and our test size should be 0.2, let's say. Okay, 0.2 means 20%. Okay, 20% of the data I am using for test. I told you that generally 10% of the data is used, right? But why we are using 20% is because we have less data. Okay, and random state equals 0. So this random state means that your test split and my test split is same. Otherwise, it will be different because it distributes it into training and test set randomly. So if we keep random state as 0, then your test split and my test split will be same. It is giving a parity to randomness. Means that it is not random, but it is still random. But if I keep random state at 0, then your split, my split, and everyone's split will be same. Okay, if we keep this different, then it's also fine if we keep this different, but you will say that, sir, why my data is different, why your graph is different. That's why we keep this random state as 0, so that our data is similar. Okay, if we have done this, then we will run this and it is run. Okay, so if you have run this, then say done or yes in the chat box. Thank you so much, those who are already replying. Okay, so we have now trained and test. Now we have data which we have divided into training set and test set. Now the important part, which is we will train this simple linear regression model on the training set. Okay, let's train this. So to train this, we will require another library, which is called linear regression. So we will again go to scikit-learn and type here linear regression. Okay, because we are doing linear regression. So we'll go to this linear models and we see that same thing, like it also explains like ordinary least square method, that we are fitting this line, all these data points. And it also explains everything, why we need non-negative least squares, what is ridge regression, classification, what is all of that, it explains, right? But what to use, what code to use here. So from scikit-learn, we import this linear model, and from linear model, we will use this linear regression class. Okay, so this we learned from scikit-learn. So we go back to our code. We typed from scikit-learn, sklearn dot model selection. Sorry, no, model selection was not there, right? Scikit-learn dot linear model import linear regression. All right, so no need to even remember any code. If you know that scikit-learn is the library, you go to scikit-learn, you can see how you can code in scikit-learn. All right, so my idea is not to teach remembering the code, but to understand how to write that code. Okay, so from scikit-learn.linear model, you import this linear regression class. Okay, now this class itself will not work, so you will need to create an object of this class. If you know anything about object-oriented programming, then this is a very simple concept. But if you don't know about that, then how to simply put it is that there is linear regression is kind of like a class. If you want to, it's kind of like a base model. If you want to use it, then you will take the base model and create. It's kind of like a blueprint. You will create a base model and use that. Okay, so that's the best way of describing why we are creating the object of this class. Okay, so we'll create an object of this class, regressor, which inherits all the properties of what is there in the class. Basically, we are creating another object out of that blueprint, and we will use that linear regression class, and we make an object of it. So this linear regression we imported, And this regressor, we made an object of this linear regression class. Okay. So we will use this regressor to fit a line on what? Our training data and Y train. Okay. So three things we did from scikit-learn. We imported linear regression class. We made an object of this linear regression class, which is called regressor. And we fit this to fit a line on my training data. So I put two variables here, X train and Y train. So I fit this line on X train and Y train. Okay. So I run this code and it is executed. Okay. So from scikit-learn, I import this linear regression class. I made an object regressor and I fit this to fit a line that best maps my training data, X train and Y train, right? That's what we are doing in supervised learning and linear regression. Okay. Now let's predict the test results. Okay. So we have done it with training data. Let's see what is our test data. So we make a prediction, which we will call Y predict. Okay, we make this variable Y predict, and we are predicting on the base of this. Okay, on the base of the line that we have found the best fit, we are predicting our results for the test set. Okay, so we will use this regressor again, regressor, and we will use this predict function to predict X test. Okay, those who are not understanding this code, I'm going to explain it one more time. So we imported this linear regression class from scikit-learn.linear model, and we made this object of this linear regression, and we fit this to fit a line on X train and Y train. Basically, we are working on a training data, and now we predict the test set results. That means that we are trying to predict what are our test set results. So we made a Y predict variable, and we predicted it by using a predict function from the regressor class, regressor.predict, and we predicted all the Y variables on X test. Okay. All right, now just run the code and the prediction is done. Okay, so if you have done this code, that means that training the simple linear regression and the test set results, please type done or yes in the chat box. Thank you so much, those who are doing it with me. That means that you are setting a pace in this class. That means you are focused and you are taking an ownership of learning machine learning. All right. Thank you so much, those who are replying with yes and done in this class. Those some have some errors. Error में एक बार सब हो जाएगा ना, then I will remove all the errors. ठीक है, so I will explain everything. Shubham says that why is X variable capitalized? It's their way of using it. So हम तो small ही use कर रहे हैं. So we will use small. एक एरर ये आ सकता है, जो scikit-learn से कॉपी कर रहे हैं वो लोग X कैपिटल मिलेगा उनको. ठीक है, तो वो हमने तो X हमेशा स्मॉल रखा है, तो एक वो ध्यान देना है. That is one error that you can get. Other error that you can get is maybe instead of test size, you are just writing size, and other errors might be spelling errors. Apart from those, you will not get any other error. Okay. Okay. So one more error you can get if you have not executed this code. Okay. So if you have not executed this code, but directly this code you have run, so error will also come. So you have to execute this, and then execute this. Okay. All right. Why are we using scikit-learn? Harshvardhan is saying because scikit-learn is a vast library that is being used by scientists, so that we are not reinventing everything again. So scikit-learn has everything in its repository, like linear regression. It has multiple linear regression. All the machine learning models are there, and it is very simple to use. It is explanatory. You can just go to the scikit-learn website. You can see all the explanations of whatever they have created in the website itself. So it's a good way to use. That's why we are using it, right? Now let's visualize it. Let's plot some graphs. Okay, so let's visualize the training set results, how our line looks like and how our data sets are. Okay, so let's see that. So we will use this. We already imported this matplotlib library right here as PLT. So we will go to PLT, and PLT dot, we will plot a scatter graph. Okay, scatter graph on X train and Y train, and let's color it COLOR. Remember, COLOR is the color, and let's color it blue. So we are plotting a scatter graph. Scatter graph means that we are plotting something similar to what we have here. Okay, this graph. So on the base of X values, we are plotting this Y. Now, why is it a scatter graph? Because it's not a continuous line. We have data points which are not continuous. We have different data points, and for those data points, we have the values of Y. So we'll plot a scatter plot. So for that, we'll use the scatter function, plt.scatter, and in this scatter function, we will